Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 30, Types of Chemical Reactions, Part 5. Here are our objectives for today's video. Pause here. So you've heard the term acid and you've heard the term base before. All acids are any substance, anything that is able to lower the pH of water. pH, if you didn't already know this, is called power of hydrogen. It is equal to the negative log of H+. If you don't know what that means, it's not a big deal. That's something that we talk about mathematically in AP chemistry once you've taken pre-calc and have a little bit of background on what that means. What I will tell you is that anything that increases H+ concentration decreases pH. There are many ways that that can happen, but we're going to talk about one of those ways, which is an Arrhenius acid. They release hydrogen ions when they dissociate in water. So those are our classical acids, our hydrochloric acid, our sulfuric acid. All of the things when we were doing nomenclature, we saw that they started with H. Whereas Arrhenius bases, these are things that release hydroxide ions when they dissociate in water. Sodium hydroxide, potassium hydroxide, magnesium hydroxide. All of those are going to be bases. There are other types of acids or bases. We're just going to save them for another time. Pause here. So a neutralization reaction, so the reason why it's called neutralization is because we take something that is acidic and we make it no longer acidic. It's very similar to a double replacement reaction. The only difference is instead of forming a solid, we are forming water, liquid water. The net ionic equation of every single neutralization reaction that occurs between an Arrhenius acid and an Arrhenius base will be the formation of water. The reason why is because you've got the H+ coming from the acid, you've got the OH- coming from the base, they come together and they form HOH, which we can rewrite as H2O. If you prefer to leave it as HOH for the purposes of making balancing the equation easier, that's completely fine with me. It means the exact same thing. Pause here. Great, I will work through this with you. Yeah, looks like there had already been a take of this video before. So you have to remember your nomenclature. I would suggest for some of the more common ones, it isn't a bad idea to just have them memorized. So magnesium hydroxide is not soluble in water, so I'm going to make it a solid. That being said, it is debatable. If you could put it as a AQ, and that actually could debatably be correct. Just need to balance this equation. And then I happen to have the net ionic equation copied because I knew I would need it twice. And then the spectator ions are pretty much the things that are not H+ or OH-. While it is possible for a solid to form, it's really, really unlikely. Pause here. So this is a stoichiometry calculation. This one is for a double replacement reaction, but it could just as easily be for an acid-base reaction. The math is pretty much the same. This is something you should be able to do without too much difficulty, but I wanted you to have seen at least once before. Before doing any sort of stoichiometry things, you're going to need a balanced chemical equation. So I'm going to start with the factor in the problem that is not molarity. I've got 63.2 milliliters. And that is 4 molar NaCl. And then otherwise, this is more or less just a standard stoichiometry calculation. Because my 4 only has one significant figure, my final answer here can only have one significant figure. And I end up with 40 grams of AgCl. Thank you so much for watching and have a great night.